Okay, so in this series I'm fusing together two or maybe more topics, and in this one I'm going to be looking at sectors of circles and then the area of a triangle, and actually my final question is going to have some percentages in as well. So I'm not trying to teach you these things. These beginning parts are just recapping and a quick bit of revision, and then we will do a tough exam style question that I've got here and then one for you to try. And I'm also going to link in the description that this is actually inspired by a past exam question, so you can also have a go at that one afterwards. So the first kind of thing that we're going to recap is the area of these shapes, and all of these shapes are triangles. Now we should know that there are two formulae for the area of a triangle. There is either base times height divided by 2, or the other version is that the area is equal to a half AB sine C, where C is the angle between the sides A and B. So you may need to recap these things, but this is just a quick go at these. So for this first shape, we can just say that the area of this triangle is just the base, which is 6, times the height, which is 4, divided by 2. And 24 divided by 2 is 12 centimeters squared. Now the area of this triangle is just the base times by the height, divided by 2. That's 28 divided by 2, which is 14 centimeters squared. Now these ones we can't just do the 9 times 6 and multiply them and divide it by 2, because they're not perpendicular to each other. The base and height for this formula must be perpendicular for it to work. So here they're not, so instead I'm going to use this formula. Now a half AB sine C is when you have a triangle, the angle is C and A and B are the two sides that are either side of the angle. Perfect, like this one that we've got here. So you're going to allowed to use a calculator for this. The area of this triangle is going to be a half multiplied by, it doesn't matter which one is A and which one is B, but we're going to multiply by the sine of the angle in between, which is sine of 50 degrees. And I'm just going to put that on my calculator. So I'm going to do a half multiplied by 9, multiplied by 6, multiplied by the sine of 50, and we get that the answer is 20.7 to 1 decimal place, 20.7 centimeters squared. Now in this one that we've got here, we need to just make sure we can select the correct numbers. So it's going to be a half AB sine C, but the ones that you use are the two sides that are either side of the angle. So the 11.3 here will not be used. The area is just going to be a half multiplied by the 10.2 and the 7, and the sine of the angle in between, which is 80 degrees. So I'm just going to work out a half multiplied by 10.2 multiplied by 7 multiplied by the sine of 80. And to 1 decimal place, that is 35.2 centimeters squared. So you're going to need to make sure that you know how to do these things for the question that we've got coming up. Next kind of thing are to do with sectors. So we've done the triangles part, we're now going to do the sectors parts. Now what you need to remember is that the area of these shapes, which are all related to circles, are going to be something to do with pi r squared, obviously where we have the radius squared here. So this first one is just going to be pi multiplied by 4 squared. And again, I'm going to just do this to 1 decimal place. So I'm just going to do shift and then get pi, which is down at the bottom, and multiply that by 4 squared. We don't want the exact form, we want it in a decimal form. So we have 50.3 centimeters squared. Now you need to be really careful on this one because we don't actually have the whole shape. The amount of the shape that we've got here is we have 3/4 of the whole shape. We have 3/4 of a circle. So what we're going to do for the area of this shape is we're going to also get the answer and then multiply it by 3/4. So I want to have 3/4 of the full area, which would be pi multiplied by the radius squared. So I'm just going to type that on my calculator. So I'm going to do 3/4 of pi r squared. And so the area of that shape is 58.9 centimeters squared, also to 1 decimal place. This one is just half of a circle. So this is a semicircle or a half circle. So what I'm going to do for the area is I'm going to do a half multiplied by pi r squared. And this case, the radius isn't 7. The radius is half of that 7. So the radius is just going to be 3.5. So I'm going to multiply that by 3.5 squared. So let's do a calculation. That is going to be a half multiplied by pi multiplied by 3.5 squared. And to 1 decimal place, that is 19.2 centimeters squared. Now this one is more complicated because we have an angle here and we need to figure out what that angle is as a fraction. So in this first one, it was pretty obvious that it was, or the second one, sorry, it was 3/4, pretty obvious. Half, pretty obvious. But this time we've been told it's 150 degrees. So we need to think what fraction of a circle that is. Well, it's 150 out of 360 degrees. So because we have a calculator, I'm not even going to simplify that. I'm just going to say that I want 150 out of 360. I want that fraction of the circle's area, which is going to be pi times 2 squared. Now, if you want to see what 150 over 360 simplifies to, it simplifies to 5/12. So we've got 5/12 of the area. I'm going to multiply that by pi, and then I'm going to multiply that by the radius squared. Press the SD button, and we get that the area is 5.24 centimeters squared, and that is to, oh, I've done that to 2 decimal places. I should have done that to 1 decimal place, which is just going to be 5.2, because I've been doing all of my answers so far to 1 decimal place. Okay, now we're going to do the last part of the question, which says, work out the area of the right-angled triangle from 1 as a percentage of the area of the semicircle from 2. So to do a percentage, we're going to do the triangle out of the semicircle. That would be as a fraction. And then to change it to a percentage, we just multiply it by 100. So the right-angled triangle's area was this one, which was 12. So it is going to be a 12. The semicircle was 19.2. In fact, I might do that with a few more decimal points. So that was going to be, we've got that here actually. It was, oh, I don't actually have it, or do I? Yeah, here it is, 19.242. Let's do 19.242, a few more decimal points so we get a more accurate answer, and then we're going to multiply it by 100. So I'm going to do 12 over 19.242, change it into a percentage by multiplying it by 100, and that's going to give us 62% to the nearest percent. It didn't say what percentage to give it to. Let's do 1 decimal place, let's do 62.4. So 62.4%. It is saying that the triangle is 62.4% of the area of the semicircle. So let's try and blend these two things together in an example problem. This is a 5-mark exam style question. It's been inspired by a question from June 2007, paper 2, question 17, and you can have a go at doing that one, which I've linked in the description afterwards. So let's just read what it says here. It says that ONQ is a sector of a circle. ONQ. It literally just means like, I don't know, like a slice of the circle. And it says center is O and the radius is 12 centimeters. So they don't always give you this information, but I'm going to want to put that on the diagram just to make sure that I know that this is 12 centimeters. It then says that A is on the point ON, great, I can see that, and B is on the point OQ, such that OA is equal to OB, which is equal to 7. So that means that this distance here is 7, and also this distance here is 7. Now, before I even read what the rest of the question is, as soon as they tell me something like this is 7 and this is 7, I like to think to myself, what else do I know? Well, because those two lengths are equal to each other, we know that this triangle is a particular triangle. It is an isosceles triangle. And because it's an isosceles triangle, we can do some other work with it in a second. We'll also notice they've told us that this angle here is 30 degrees. Could be useful in a little bit. Just going to move that there. It says calculate the area of the shaded region as a percentage of the area of the sector ONQ, and give your answer correct to 1 decimal place. So let's start off by finding the area of the shaded region that we've got. Okay, well I want to find the area of this triangle. That's all it's really asking for me to do. But if I wanted to do a half AB sine C, I would need to know how long that line is. I know how long that one is and that one is. So what I really want is to find out this angle that's here, because then I could do a half AB sine C. Well, this fact is going to be really useful because this is isosceles. I know that this angle at the top here is 30 degrees. And because the angles in a triangle add to 180, I can do 180, take away 30, take away 30. That is just going to be 120 degrees for this part that we've got here. So the shaded region is going to be a triangle that looks like this as my sketch. There's 120 there. That is a 7 and that is a 7. So I can work it out by doing a half multiplied by A multiplied by B multiplied by the sine of 120. And I'm just going to go straight to my calculator and put that on. So that is a half multiplied by 7 multiplied by 7 multiplied by the sine of 120. So that is 21.2176 ... And now I'm going to find out the area of the sector. Okay, so I'm going to do the sector area. Well, that's good because we've worked out that this is 120 degrees. Now, if it's 120 degrees out of 360, you might just know what that is. 120 out of 360 is just a third. So you could either write a third, but because we've got a calculator, we can just go straight in with this. And we're going to do pi multiplied by the radius squared. Now, the radius of this sector is 12. So we're going to be multiplying it by 12 squared. So let's put the calculator on this side. We'll do our 120 out of 360, which we said is a third. And we're going to multiply by pi. And then we're going to multiply that by 12 squared. So that we get the answer 150.796, blah, 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 blah. So all that's left to do is to just say this last part where it wants us to say the area of the shaded region as a percentage of the sector. So we're going to do the shaded divided by the sector, and then we're going to times it by 100. Now you could either do this in one single calculation from the beginning. You could have just done that, divided by that, and times it by 100. But seeing as I've got the numbers, I'm just going to do 21.2176 divided by 150.796 and multiply it by 100. Because it wants it to one decimal place, I've just given a few extra just to make sure that I get an accurate answer. So I'm going to do 21.2176 over 150.796, and I'll multiply that by 100 to get it as a percentage. And to one decimal place, that is going to be 14.1%. So the answer is 14.1%. Okay, so you might have a go at doing this question. So I've got one that is kind of similar, and just read through it, see if you can have a go, pause the video, and then check with me afterwards if you've got the same answer. Okay, I'm just going to put this calculator to the other side here. Let's read through what it says. So it says OPQ is a sector of a circle with center O and radius 15. I'm immediately just going to say then that this radius is 15 centimeters. It then says that OAB is an equilateral triangle. Okay, well I know something about an equilateral triangle. I know that when I have an equilateral triangle, all of the angles inside it are 60 degrees. So I can immediately say that this angle here is going to be 60 degrees. A is the point on OP such that, and B is the point on OQ such that both OA and OB are equal to 11 centimeters. So I can say that this distance is 11 centimeters, and also I can say that this distance here is 11 centimeters. And because it's an equilateral triangle, in fact that distance across the top is 11 centimeters as well. That might be useful, but it might not be. Calculate the area of the shaded region as a percentage of the area of the sector OPQ. So the shaded region this time is a bit different because the shaded region is just this top section. It's the whole thing, but with the triangle removed from it. So I think what we're going to say is that the shaded region is going to be equal to the OPQ region, which is this, minus the triangle. So we need to find out what those other areas are first of all. So the area of OPQ, which is that sector, it's 60 degrees here, and the radius is 15. So it's going to be the 60 out of 360. You might recognize that 60 out of 360 is a sixth. And we're going to multiply that by pi and the radius squared. So OPQ is going to be 60 over 360 multiplied by pi multiplied by 15 squared. And we get 117.8097. I'll just do a few decimal places. That's going to be centimeters squared. Now we're going to try and find out what the area of the triangle is. The triangle is OAB, and it's going to be a half AB sine C. So it's going to be a half times the 11 times the 11 times the sine of 60. So let's calculate that as well. That's going to be a half multiplied by 11 multiplied by 11 multiplied by the sine of 60, which is 52.3945. Now we're going to try and come up with the different answers. So we've just said that the shaded area is going to be these things. Let's take that bit. Let's put that here. So we're now going to find out what the shaded area is. It's going to be the sector one, which is 117.8097. Subtract the other one, which is 52.3945. That's going to be our shaded area, which is that top section. So I'll do 117.8097 minus 52.3945. So it is 65.4152. And now we just need to answer the question because we've got enough information. It says calculate the area of the shaded region as a percentage of the sector. So I'm going to do for our calculation the shaded region out of the sector. The sector one was this, which is 117.8097, and we'll make it become a percentage by timesing it by 100. Now, obviously, you might not need this many decimals, and you could do this as one single calculation if you wanted to. So I'm going to do 65.4152 over 117.8097, multiply it by 100, and we get that the answer is 55.5% to one decimal place. 55.5%. Now, if you did want to write it as a single calculation, it would be a little bit more complicated, but you could have just said that the shaded area was going to be our 60 over 360 multiplied by pi multiplied by 15 squared minus our half times 11 sine 60, all divided by the 60 over 360 times pi times 15 squared, and then you get that answer and multiply it by 100 because you've got the sector, the triangle, you subtract them for the shaded area and you divide it by the sector to make it become a fraction and times it by 100 there. So you might like doing it in that kind of way if you feel very confident you've got all of them right, but I think it's useful to see them as numbers as well. So I'm going to also link in the description June 2007 paper 2, question 17, if you want to do another one that is very similar to this. Hopefully these are going to prepare you really well for your exams. If you like this kind of thing, subscribe to my channel just to make sure that you're always keeping in the loop with all the stuff that I'm putting out.